For this video, we're going to be taking a look at a few interesting things that happen when we investigate the angles both inside a triangle and angles that'll show up outside a triangle. So we're going to jump in and take a look at something called the triangle angle sum theorem. And so what it says is if we look at the three angles inside a triangle, the sum of those angles will always be 180 degrees. So in other words, in this picture over here, if I took the measure of angle A plus the measure of angle B plus the measure of angle C, I'll always get 180. Now this is a theorem, and theorems can always be proven to be true. So I want to take a minute or two and I want to go through how we would know that in this picture here, these three angles would have to add up to 180. And so this is going to be a proof of this theorem, a proof of why it has to be true. So the first thing we're going to do to prove that these three angles add up to 180 is we're going to draw a line that goes through C and that's parallel to line AB. There would only be one line that you could draw that would do that. It would maybe look something like this, so that this is parallel to this. Now, when that happens, we can look at a couple relationships that end up. And what I'm going to do is I'm going to extend this line and I'm going to extend this line. All right. Now, if I look at this picture, I know that this angle right here and angle 2 would be congruent to each other because they are alternate interior angles for these lines right here being parallel and then line BC being a transversal. Why don't I go ahead and extend for a second? I'll extend line BC too, so we can kind of imagine that going on. And I'm going to name that line, or that angle, angle 4 there. I know that angle 2 is congruent to, or the measure of angle 2 is equal to the measure of angle 4 because they are alternate interior angles, and alternate interior angles are going to be congruent when I have these parallel lines. Now I also know that if I take this angle, angle 1, and I add it to the combination of angles 3 and 4, that should add up to 180 because this angle and this angle right here are same side interior angles. So maybe to make this clear, I'm going to label a point out here. I'm going to call it point D. I know that the measure of angle A plus the measure of angle ACD should equal 180 because same side interior angles are always going to be supplementary. But then I also can say, well, the measure of angle ACD is equal to the measure of angle 3 plus the measure of angle 4. And we know that this angle, its measure is angle 3 plus angle 4, and that's the angle addition postulate. So then if I come back up to this statement right here, I would be able to say that angle A, or I'll call it angle 1, plus angles 3 and 4 should add up to 180. Measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 should equal 180. And all I did was I substituted in this statement right here, where A plus ACD equals 180, I just turned angle A into angle 1 because it's the same thing. And then I had already said that angle ACD is angle 3 plus angle 4, so I'm going to replace the angle ACD right here with angle 3 plus angle 4. Then I'm going to replace this angle 4 with angle 2 because right up here I said that those are interchangeable. They're equal to each other. So measure of angle 1 plus the measure of angle 3 plus the measure of angle 2 equals 180, and there I've got a statement that says, hey, these interior angles are going to add up to 180. So that's kind of the way we would prove that in this picture angles 1, 2, and 3 would have to add up to 180. It all comes down to adding this one parallel line here and then looking at some of the relationships that we've learned about with alternate interior angles and same side interior angles. Now the next thing we're going to take a look at is called the triangle exterior angle theorem. And so if I look at my picture over here, you can see I have a triangle, but then I took this bottom side and I extended it out past this corner of the triangle. And when I extended that out past there, I created this angle number 1. that is considered to be an exterior angle of a triangle. I could do the same thing by extending this side right here. I could extend it out this way, and this I could extend the other side out this way, so I could create an angle here. We could call it angle 4. I could create an angle out there, call it angle 5. Right? I can extend each side of that triangle and create an exterior angle at each corner. But let's look at angle 1. Angle 1's measure is going to be equal to the sum of the two, what we call remote interior angles. And when we say remote interior angles, what I'm talking about is the interior angles on the triangle, the ones inside the triangle, that are not directly next to the exterior angle I'm looking at. So if I'm looking at angle 1, angles 2 and 3 would be considered the remote interior angles, because they're not the one that's directly next to angle 1. They're kind of on the other two corners of the triangle. So in this picture over here, I would be able to say, if I have that picture, the measure of angle 1 would be equal to the measure of angle 2 plus the measure of angle 3. And now we're going to take a look and we're going to prove how we know that to be true. And we're going to start that off by adding in another parallel line here. So I added a line to my picture, and I'm going to say that that line is parallel to this one. When I added that line in, it created angle 4 right here. Now I know that angle 2, the measure of angle 2 is equal to the measure of angle 4, because they are alternate interior angles. And then I also know that if I add angle 1 to the combination of 3 and 4, I should get, or they should be equal. Angle 1 is equal to the combination of 3 and 4. So let's state that. The measure of angle 1 should be equal to the measure of angle 3 plus the measure of angle 4. And the reason that's true is because angle 1 and that angle formed by combining angles 3 and 4 together are alternate interior angles. Right? This angle right here and angle 1, they're alternate interior angles, so they need to be congruent. But then right up here I said angle 4 is interchangeable with angle 2. They're equal. So I can say that the measure of angle 1 would equal the measure of angle 3 plus the measure of angle 2. And now I've just proven this theorem up here, that this exterior angle would always be equal to this angle plus this angle added together.